This is our final video in order to revise for our space test, and it's the last one, and we're looking at how do we cause an eclipse. We have two types and you have to be able to explain each one. You've got a solar eclipse and a lunar eclipse. These can be full or partial. We're just going to look at the difference between the two. So you've got to be able to recreate both these diagrams. The key thing is to simplify them. Always have your sun drawn on the left hand side. Label that as an S. And then you've got two options. You're either going to have the Earth next, which is obviously slightly smaller than the sun, and then the moon, all in alignment, which again is smaller than the Earth. Or you're going to have the moon, which is the smallest of the three bodies, followed by the Earth. So these two are the opposite of each other if we look at it. For the lunar and solar eclipse, the position Sun, Earth, Moon, or Sun, Moon, Earth. The difference between the order tells us whether we're going to get a lunar eclipse or a solar eclipse. So we'll start with what happens in a solar eclipse. So a solar eclipse will only occur at a new moon. So thinking about our phases of the moon here, this has to be a new moon position. Remembering if it's on the other side, so here would be a new moon position, as it moves round and it's on the other side of the Earth, this would be a full moon position up in this position here. So it has to be in the new moon position. Solar eclipses, these are a happy accident of nature. By chance, the sun's 864,000 mile diameter, so this here is 864,000 miles in diameter. And that's 400 times greater than the diameter of our moon. So this is 400 times the size of poor little moon over here. But the moon also happens to be about 400 times closer to Earth than the sun. So if we're measuring this distance here against this distance here, this distance is 400 times closer than the distance between the sun and the moon. And as a result, when the orbital planes intersect and the distances align favourably, the new moon can appear to completely block out the disk of the sun. On the average, a total eclipse occurs somewhere on Earth about every 18 months. It doesn't happen every time we have a new moon. So everything has to be aligned, and due to our axes, this is not going to happen once a month on the new moon. It's going to happen roughly about 18 months apart. There are actually two types of shadow that we would see. The umbra is the part of the shadow where all sunlight is blocked out. So that would be in this cone shape here. So if you were on this bit of planet Earth, so if you were at this point here when the eclipse was taking place, you would be in complete darkness. The umbra takes the shape of a dark, slender cone, and it is surrounded by the penumbra, which is a lighter, funnel-shaped shadow from which sunlight is partially obscured. So if then you were at any point in this area here, or this area here, you would have a partial shadow. During a total solar eclipse, the moon casts its umbra upon Earth's surface. That shadow can sweep a third of the way around the planet in just a few hours. Those who are fortunate enough to be positioned in the direct path of the umbra will see the sun's disk diminish into a crescent as the moon's dark shadow rushes toward them across the landscape. So that's the solar eclipse done. Looking at the lunar eclipse then, an eclipse of the moon or lunar eclipse can only occur at full moon. So the moon has to be in the position where the Earth and the sun are all in alignment, but the moon must be on the far side of the Earth. Only if the moon passes through some portion of Earth's shadow. That shadow is actually composed of two cones, again the umbra and the penumbra. It's exactly the same, the umbra, but this time the umbra is much wider. So this area here, if we think about it in terms of size, when that moon then is moving, because the umbra for a lunar eclipse is much greater, so this is the big thing, the umbra is larger in diameter for a lunar eclipse, which means that a lunar eclipse is going to last much longer. Because this moon here is orbiting Earth, and once the moon gets into this section here, it still has to move and keep orbiting around the Earth. And obviously that's going to take longer than if we think over on this side over here, the moon's going to move, and very quickly, once that moon moves out of that position there, the Earth is no longer cast in shadow. Where on this side, the moon is going to stay in the Earth's shadow for much longer. So it lasts longer because the umbra is larger, and therefore even when the moon is orbiting, it's going to take a lot longer for it to come out of the shadow of the Earth. Because of the moon moving around the Earth is only going to stay in the moon shadow for a very small amount of time. Remembering we're all orbiting around the sun and the sun is not moving at any point. So that's the key point. Remember the order: Sun, Earth, Moon for a lunar eclipse, or Sun, Moon, Earth for a solar eclipse. Know the terms umbra, complete darkness, or penumbra, so partial shadow. And know that the lunar eclipse is going to last longer and be able to explain why. Thank you for listening.